Hello, in this video we'll talk about the simulation of predictive parser, which is the seventh experiment of our system software and compiler design lab. Predictive parsing is the one of the top-down parsing method. The top-down parsing method means we construct the syntax tree, which is the output of our second phase of the compiler, which is syntax analysis phase. The top-down parsing method, it constructs the tree starting from the root towards the leaves. So we'll see what are the requirements for doing this parsing method. So recursive descent parsing is one of the forms of top-down parsing. Here we have both backtracking as well as non-backtracking method. So this predictive parser, it comes under non-backtracking method, and this predictive parser, it uses the LL grammar. LL grammar, it represents the it is similar to doing the leftmost derivation, this top-down parsing. So here this LL represents the L represents the input will be scanned from left to right, and this L represents here we are going to have this as either leftmost derivation we can say, or it can be the look ahead. And so for doing this predictive parsing, we have a model which corresponds to a predictive parsing table. So the model of a table driven predictive parser is that we have an input buffer where we have the input string, which is entered by a special symbol, which is the dollar symbol, and we'll have a stack. So the bottom of the stack again is represented by the symbol dollar, and then we will have the other symbols which we are going to push into the stack. And we have a parsing table which we can construct from the given grammar based on the first and follow functions. So the parsing table will be helpful in implementing this predictive parsing algorithm or the program. So by that we get the output for the given input string, the whether the string could be parsed by the given whether the input could be parsed successfully or not. So for this predictive parsing algorithm, the input is we need to have a string W, and then we need a parsing table. Let us call that parsing table as M. So an input so the input string is stored in a input buffer, and we also have a parsing table M. So these two are the inputs for the predictive parsing algorithm. And what would be the output is if W is in, so we use a string as input. So if this W, it belongs to the grammar G or the language generated by the grammar G, then we will get a leftmost derivation of that string. If not, if the string is not present in this grammar or the language represented by this grammar, then it will give an error indication. So how this parsing program works is that, so we have a input string in the input buffer. So first we scan the input from left to right. So at each step we read from the left, and so let A be the first symbol of the given input string. So of course here we also have an input symbol A for the first symbol, but then this A represents the very first symbol of our input string. And then the now here the X represents the top of the stack. So this represents the top stack symbol, and So we are going to repeat this process till the stack becomes empty. So every time it checks whether the top of the stack is a dollar or not. So if it is not a dollar, then we have some more elements in the, we have some other element in the top of the stack. So every time we check the, what is the top of the stack. If the top of the stack and the first input symbol in the um, string matches, okay, so if the string as well as your, if this x is equal to a, that is the top of the stack is going to be a, then this symbol that we read in the input buffer and the top of the stack matches. In that case, we pop that symbol from the stack, and then the next symbol becomes the um, uh, then the next symbol in the input buffer becomes our input. And so then we check if suppose if these two doesn't match, and if this is some other terminal, okay, if this is some other terminal, say let us say b, and here in input we have a, so it doesn't match. So in that case we cannot proceed further, and it represents a error entry. And then we if that is not an error, then we go for looking into the table. We look into the parsing table. So if this top of the stack is some variable, then we look into the parsing table entry. What is m of x comma a? So in the table, what is x on a, we need to check. So this entry uh, will help us to proceed with the procedure. So if this is again an empty cell, okay, if there is no entry in this table, then again that is a error indication. But if we have some entry, some production in this table entry, something like this, x gives y1 y2 up to yk, okay, it can be any production. If this production is available in this entry, then we output that production, and we pop the stack symbol and replace that by pushing this output production into the stack. So while we are pushing the while we are pushing this production into the stack, we are going to push only the right hand side, and that has to be done in the reverse, okay, so that this leftmost variable, that is leftmost variable or terminal, whatever that is present in the body of the production, that has to be in the top of the stack. So we push in the reverse order, so starting from the last symbol of the body of the production, from yk minus 1 up to y1, and we have to push it into the stack having y1 in the top. So now again that becomes the top of the stack. So this is the overall thing of this table driven predictive parser. So how this predictive parsing table will be constructed is based on the first and follow functions that we found. I hope you know how to construct the first and follow functions. So for constructing the predictive parsing table, we need to have a grammar, and the requirement for doing this top-down parsing is that it should not be left recursive. If the grammar is having left recursion, then that has to be removed. So it should be non-left recursive grammar, and also it should be left factored. The grammar should be left factored, and one more requirement is that it should be unambiguous. So these three things, uh, when the grammar is satisfying all these three conditions, then we will be able to do the predictive parsing, that is the top down parsing method, successfully. So we have the grammar, then a parsing table. The output would be this parsing table. So how we do that is, for every production of the grammar, say A gives alpha, then we need to do the below things for every production. So for every production that we have, whatever the production it may be, we need to find the first for that. So the whatever we have, for example, we have a production like this. So then what is first of A is, we'll be getting the terminal A. So in the table entry, so when we have A on A, we have to, this particular production has to be written on the terminal which is found in the first function. So we'll be getting the thing here. So now for all the terminals that are present in the first function, we have to add the corresponding production in the table. And if we have a production, say A gives epsilon. So for A gives epsilon, we need to find what is the follow of A. So we need to find the follow of this left hand side variable. And so let us say in this case we have only dollar as follow of A. So under dollar we need to write that production A gives epsilon. If epsilon is present in first of alpha, then for every terminal that is present in follow of that variable, we need to add that production in the table for every follow that is available in the set. And if we have both the dollar as well as some other follow terminals, everywhere we have to include that production. So after applying this first and follow function and make entries in the parsing table, if some of the entries are empty, then those entries we call it as the error indication. That entries, empty cells will represent the, it will indicate that there is an error. So now here we take an example grammar, and this is a parsing table that is constructed for this given grammar, and this is a sample input string. So as you find first and follow for this particular grammar, you'll be able to construct this parsing table as per the algorithm that we have discussed now. So this input string we have taken here, and you can see how it has to be processed. So as we have seen in the model driven predictive parser structure, we should have the stack, and then we have the input string that should be ended with the dollar symbol, and the stack, bottom of the stack should be dollar symbol. So now here, so we have the bottom of the stack as dollar symbol, and then initially we should have the starting symbol of the grammar as the top of the stack. So now initially the top of the stack should be the starting symbol of our grammar. So here we have in this particular grammar, if we see, E is the starting symbol of the grammar. So we push the starting symbol into the stack, and that becomes the top of the stack. So now each time we need to check as per the algorithm whether stack becomes empty, that is whether the top of the stack is dollar or not. If not, then we have to check what is the top of the stack. If that is a variable, then uh, we have to check in the parsing table what is the corresponding entry for this top of the stack and the first symbol of your input string. So when we check in the parsing table, we have E on ID. Okay, so this is the first symbol of the input string that we are reading now, and this is the top of the stack. So what is E on ID? So we have a production here, E gives TE dash. So what we should do now, this body of the production, we have to push it into the stack. And before pushing this, we have to pop what is already there in the stack. So this has to be popped out, and this body of the production has to be pushed into the stack in the reverse order. So we have dollar and E initially. So now this E has to be popped out, and then the body of the production what we are having, this has to be pushed in reverse order. So E dash will be pushed first and then followed by T. That is what we are having in the leftmost, it should be in the top of the stack. That way we need to push it into the stack. So now we have the top of the stack as T, and we have the input as ID. So still we have a variable. So again we need to go and check into the table what is T on ID. So T on ID is, we have a production here in the table. T gives FT dash. So similarly again we need to pop this, and it is replaced by the body of the production, that is ft dash in the reverse order. So t dash f. So t is replaced by here this ft dash in the reverse order in your stack. So now currently the stack will be like this e dash will be there, and this t will be replaced by the t dash and f in the top of the stack. So now we have the top of the stack as F, and the input that we are reading is ID. So we need to check what is F on ID from the table. So F on ID is F gives ID. So the body of the production we have ID. So pop out the top of the stack, and that is replaced by ID. So now we have top of the stack is a terminal, which is same as the first input symbol that we are reading in our input string. So since these two matches, we pop this from the stack, and since this becomes a matched symbol in the string, we can uh, remove this. So now the remaining input is plus ID star ID dollar. And now the current top of the stack is t dash, which is a variable. So again we need to check from the table what is t dash on plus. So for t dash on plus, we have got a production here saying t dash gives epsilon. So it means that we simply, so this is already matched, so it will be removed. Now the current top of the stack, this t dash, it is replaced, or it is popped, and that will be replaced with epsilon. And so if we push epsilon into the stack or not, it is going to be an empty thing. So now the current top of the stack will be E dash. So again you need to check for the so T dash is popped out, and what we have now is E dash as the top of the stack. So again you have to check what is E dash on plus. So E dash on plus, we have the production E gives plus TE dash. So E dash will be popped out, that is replaced with plus TE dash into the stack. So while you are doing so, plus has to be in the top of the stack. So this your thing becomes, this E dash will be popped, and you should have plus in the top of the stack. So this is how your stack will look like at this point. Now again, in the current input symbol that we are reading, and your top of the stack matches, so it means it gets matched, and we can pop it out from the stack, and the input symbol is matched now. So the next input symbol to be read is the next symbol ID. So now we have to again check what is T on ID. So you'll be getting T gives FT dash. So T is popped out, and it is replaced with the right hand side, that is body of the production, into the stack. So now F becomes the top of the stack. Now again you check F on ID, so it becomes ID. Okay, so now then ID and ID gets matched, the inputs, so that is cancelled. So now the top of the stack is T dash. T dash on star, it gives T dash gives star ft dash. So you can see here this is popped out, and it is replaced with star ft dash. So now star and star again matches. Okay, so as you can see here on this side, as we keep on matching the symbols, the matched symbols is written over here. Here plus is matched, so it is written. Then ID is matched, so it is also written here. And now star is matched, so we write this symbol here. And then again, so we have now F on ID, so we have to write that into the, so this again ID and ID gets matched, so we write it into that. So now finally we have now T dash on the top of the stack and dollar. Okay, so the procedure has to repeat until stack becomes empty, that is stack should get dollar as its value. So now still we don't have dollar as the top of the stack in the stack. So T dash on dollar, again we need to check. So T dash on dollar is T dash gives epsilon. So it means that it gets vanished. We pop this out, and of course, since it is an empty string, uh, even if it is pushed, it is not going to have any value. So currently E dash will be the top of the stack. E dash on dollar, again we check, again that is an um, epsilon. So now this would be popped out, and finally we have only dollar as the top of the stack. All other symbols have been popped. So since we have got all the input symbols read and it is all matched, and the stack also becomes empty by having only dollar as the symbol, and here input is also all read and exhausted, and everything is constructed here as leftmost derivation. Now this parsing is considered to be successful. Okay, so this is how we need to do the predictive parsing. So when we do it in the lab, we need to give we need to give take a grammar which is non-left recursive, left factored, as well as unambiguous grammar. And for that corresponding grammar, we need to construct a predictive parsing table like this. So this has to be given as input to the in our program. Okay, so that is what is the input for the predictive parser. We need to give parsing table as input. So each entry, okay, so we can see here that for this table we have several non-terminals or the variables, and also we have the input symbols. So for each of these entry um, we need to input we need to feed the input this parsing table, and also we need to give the input string with the dollar as the end marker, and then we need to maintain a stack. So by following this procedure, by this algorithm, we will be able to identify whether the input is parsed successfully or not using this predictive parsing algorithm. Thank you.